Hi, welcome to Coding with Amadeus, episode number 3. In this video series, we're building a smart mirror using Raspberry Pi running Windows 10. In a previous episode, we built a model, view, and view model responsible for showing time for the clock component of the smart mirror. However, this time doesn't update because we ran out of time. So today I would like to continue and use a dispatcher timer to schedule all the models used by the smart mirror to update. And then we'll propagate the changes from the model to the view model. The smart mirror will consume data from many sources. It will show weather, it will show the bus schedule, it will show time. And all of those data sources need to be updated periodically. So we'll create a base class for all of those different data sources used by our smart mirror. And that base class will be, for starters, responsible for updating periodically. In the main folder, I'll create a class called base model, and the clock model will implement this type. This type will be abstract, which means that we cannot create an instance of base model, but we can create an instance of clock model, and then this clock model will behave like base model. Let's see it in action. Let's go to app.xaml.cs where we create an instance of our clock model. That will be a very good time to hook up this model to a timer. And we'll do it with the help of timer controller class. Let's create a folder for it. Add new folder, controllers. Perhaps we'll create more controllers in the future. We'll add a class timer controller. This class will be static, and timer controller will expose one static method, register model, and this method will take as a parameter an instance of base model, whether it's clock model or future bus model or weather model. Now right in this place, we'll create a timer which will update this model periodically. Universal Windows app offer us two kind of timers, dispatcher timer and thread pool timer. They're very similar and they have one subtle but very important difference. The dispatcher timer runs on the UI thread. And this is important to us because when this timer fires, it will update the model, which will update the view model, which will update the view. And the view needs to be updated from the UI thread. So if we use dispatcher timer, then everything will happen on the UI thread. Let's create an instance of a dispatcher timer. Control dot brings the usings. We see it has no parameters in the constructor, but it exposes some properties. For example, interval. Interval will tell the timer how often to fire its event. And we'll take this interval from the base model. We'll also provide the event to fire when interval elapses. So timer.tick. Here, we're working with an event. So instead of using standard equal sign, we'll use plus equals. We're assigning a new handler to this event. And this handler will be called model.timerTick. And eventually, we would like to start this timer. Let's go back to app.xaml.cs. And now let's provide this newly created clock model to the timer controller. We'll bring the usings. we'll use the right namespace. Timer controller register model, and here we're passing in an instance of clock model. And notice we do it even though register model expects a base model, but since a clock model is also a base model, this assignment will work. Let's implement the base model. Let's go back to timer controller and use control dot to generate the properties. Visual Studio just generated them for us. Interval. Every single model in our app will want to specify its own interval. The clock model will probably specify 1 second. The bus schedule or the weather forecast maybe once every 15 minutes. So let's make this interval abstract. And it needs only a getter. Now timer tick. The clock model here already has a method update. So maybe we could make this method update abstract. And now this timer tick has access to it. We'll just call update. We need to go back to clock model and tell Visual Studio that this will be an override. And what else? We need to also implement interval. In our case, the interval will be 1 second. The newest release of the C# programming language, C#6, allows us to remove this code and use a lambda in a property. Let's hit Ctrl+Shift+B to see if everything builds. Alright, it does. I think that would be a good time to save our changes in GitHub. So what have we done? We have created a timer controller. GitHub for Windows allows you to specify which files go to each commit, and you can also tell which particular lines go to a commit. So if we would like to commit only this line but not this one, we can click on this blue highlight, and now we're only going to commit this line and timer controller here. And we would also like to say that we have created the base model. And finally, we register clock model with timer controller. Alright, now let's double check that our clock model indeed updates every second. We'll set a breakpoint here in the method update and hit F5. Actually, I should have done it before committing changes to GitHub. Okay, the breakpoint hits. And it hits again. Alright, that's great. It looks like it works. We can remove the breakpoint now. Let's take a look at our clock view model. Do you remember how we implemented the iNotify property changed interface? This interface exposes the property changed event, and the view in the background is listening to this event, property changed, and it updates the bindings. We will use the very same scheme to update the view model from the model. But before we do so, I want to extract this code to its own separate class, because otherwise we will be duplicating this code for all models and view models. So let's go to the main folder and create a new class, notify property changed base, or simply property changed base. We will take this code, we'll cal it, and paste it here. We'll bring the namespaces, we need component model, and we also need compiler services. And property change base implements the I notify property changed. Great. Now the clock view model, it will no longer implement this interface, but it will implement the property changed base. Which means that this method, notify property changed, if we make it protected, will be available to other methods right here in clock view model. Since we removed this extra code that we had here earlier, we can clean up the using statements. And let's see why we have this squiggly line here. Inconsistent accessibility. Base class property change base is less accessible than clock view model. Alright, the view model is public because that's what the WPF requires. So we'll also make property change base public. Let's see if it still works, if it still updates the view. It does. Alright, let's commit our changes. Extracts notify property changed to its own type. Clock view model implements property change base. Let's do the same thing for the clock model. We can implement only one type. Here we're implementing base model, and that won't work. Class clock model can have multiple base classes, base model and property change base. But we can make base model implement that, because after all, we want all the models to be able to update the view models. Perfect, and by doing so, we can now invoke the method notify property changed from within the setter of current time. So let's refactor this current time to actually take advantage of current time field. Getter will return the backing field, and for the setter we will steal this code. It means that now whenever we call update and we set current time, we'll go to this setter, and through this if statement we'll update the backing field, and then we'll invoke the notify property changed. So the last thing we need to do is to go to the view model and listen to the property changed event, which is invoked through this method. So in the clock view model, in initialize, we can say model.property changed plus equals, because it's an event, and let's just remove the underscore. This event will fire whenever any property has changed. We want to only listen to current time being changed. So let's add an if statement. If property name equals, we'll use the name of operator, model.currentTime. So if the model is updating specifically current time, that's when we would like to invoke ours update time. I forgot a equal sign here. Let's debug and see if it works. Yes, it does. That will be a good time to commit our changes. Updates the view model from the model. So now that we have verified that the time indeed changes, I would like to tweak it a little bit. I would like to just show hours, minutes, and also current date. Let's start by updating the way time is displayed. We'll remove the it is, and we'll remove the dot, so actually we don't need the string interpolation at all. we'll just say the toString. We'll just use the toString of the current time, and we don't need to show seconds nor AM, PM. And if it's 7 AM, I don't want to display 07, I just want to show 7. And I believe that will do the trick. Let's double check. $5.13, perfect. Let's save it. Changes time format. And now let's add a date. A date will use a property called current date, which will be using a backing field current date lowercase. And when we update time, we might as well also update current date. Current date equals, and now what do we put here? Let's ask MSDN, custom date and time format strings. There's this big table here. We would like to show the day of the month from 1 through 31, so we'll take D. And would also like to show month. The full name of the month, so that's 4 capital M's. And the last thing we need to do is to update the view, to add second text block which will display the date. Let's go to the view, make it a bit bigger. Right now the text block just lives inside the grid. We would like to put in a stack panel because we would like to put multiple text blocks. Because stack panel will allow us to put multiple text blocks one on top of another. We can remove some unnecessary properties such as vertical alignment. We don't need the name since all the data is being updated via bindings. We also don't need text wrapping in this case. And horizontal alignment, yeah. We'll give stack panel a vertical alignment. Now it's in the middle. And the second text block will show current date. Let's hit F5. We see time and date. And I think we just saw the time update from 5:15 to 5:16. Alright, that's awesome. Let's save our changes, commit them. The MVVM pattern gave us a really strong foundation for the rest of the project. In the next episode, we'll talk about test-driven development, and we'll start writing tests before writing code that will run on Raspberry Pi. Introducing test-driven development will be also a good time to introduce mocking frameworks. Do you have any favorites, mock and substitute? I have a hard time deciding for what to use in the next episode. Drop me a comment, and I'll see you next time. Bye!